Hi, everyone. Good afternoon. We are just waiting for a few more people to attend, but I can see participant list going up with very friendly faces. Lots of nice people we know here. So it's great to see you have managed to join it today to take part in our Making Waves webinar. So thank you very much indeed. We will kick things off, and as we go, we'll let attendees join, but this is being recorded. So even if your friends or peers couldn't join us today, there will be a recording of this session. Okay, so I am your facilitator today. I'm Alistair Davis. I'm director of the Arribada initiative, a UK conservation technology company focused on open source hardware, research and development. And there's a little web link there if you want to look at our website. And we primarily work with conservation organizations globally to co-develop and integrate conservation technologies. One of those sectors is in Bycatch, and of course that is what we'll be focusing on today. And this webinar has all been made possible by the Open Science Hardware Foundation, or the Gathering for Open Science Hardware, GOSH. It was Jenny from GOSH who got in touch saying, what could we do in a really niche, interesting space where we could use open hardware and science to solve a problem? And I went back to Jenny and said, I think we could make a dent in bycatch mitigation. She said, that sounds fantastic. Let's host a webinar. And it's funded by the Alfred B. Sloan Foundation. And that's why we're all here today. So it was made possible by GOSH to bring us together and say, what can we do in this really interesting space? So to ask the question, why are we here today? Well, hopefully you are in the right webinar and you haven't clicked on the wrong one, and you are here today to talk about bycatch mitigation. If not, you've still got a chance to jump out. If you are in the right space, stay with us. But why are we here today? Well, we're here to ask some questions. And the kinds of questions we're going to go through, and it's a 2-hour session, but in about half an hour's time, we're going to get into an interactive session, and I'll go into that in a minute, where you will get to actually voice your own ideas as to what we do in this space. But the kind of questions I would like to pose are, for example, to ask how can we use open hardware and science to help mitigate bycatch? And we're going to have a case study showing what Arribada has done, and we'll go into a few other examples of what others have done in the community. We're probably going to ask what are the advantages and disadvantages. So we can't automatically promote openness as the all singing, dancing solution. There may be some disadvantages as well, but what are the advantages and disadvantages to working openly? Which specific challenges in the bycatch mitigation space could open science and hardware address? Potentially that isn't being addressed now, or potentially that you have an idea about that should be addressed. What are those barriers to working openly? And importantly, why are whales awesome? Which is a very important question that we'll get to later. And we're going to need some detailed responses there because it baffles me as to why they are so awesome. And coming up, we're going to have a Mentimeter session. So if you haven't heard of Mentimeter before, it's like a live Q&A with word clouds and multiple choice questions. And you can open up the Mentimeter webpage, you type in that code, and then everyone can participate together. And we did this in a session on remote plastics and tracking a week ago, and it was really successful because it's great at kind of allowing you all to have your say. And we can open up the mic and give you all a chance to talk to if you want to during that session. So later on, we're going to get into Mentimeter, so definitely stick around for that. It's a great way to interact. So looking at the agenda, we're doing the introduction right now. Then we're going to go into what is bycatch and why is it thought to occur. Now, a number of you will already be quite experienced and you're already working in bycatch mitigation or you're involved in the sector. But because we've opened this up to hardware engineers and open source developers, it may be quite new to them. So we're going to go and step through the basics and we're going to see where we get in that sense. We're going to ask both sides of the panel, so the experienced players and also any new people in this space. Then we're going to have a quick look at a case study. So in this case, we'll be looking at passive acoustic reflectors. It's a project that Arribada has worked on with CFAS and DEFRA in the United Kingdom, looking at how we can make fishing nets, especially gill nets, more acoustically visible to cetaceans. So we're just going to have a look at what that was like as a project, how openness played a part and what those barriers were and what's next, to kind of give you an idea of what goes on in the development of this space. Then we're going to have our interactive panel discussion and our Mentimeter, as I just discussed. And at the end, there will be time for questions and answers. And as we go through this, you may want to leave questions and answers as we go, or questions, the answers will come later. I think in the Mentimeter session, that's where it will be the best place to probably leave them, because we can actually open it up for debate, basically. And today we are joined by 2 panelists right now and a 3rd panelist joining us later. Our panelists today are Catherine Bell and JP Ruja. I'm just going to actually give you the mic, Catherine, so you can introduce yourself and give you video access too. You should be able to talk, Kat.
I can talk, but I'm not sure anyone can see me.
Okay, let me see if I can actually fix that for you. Do you have access to your camera?
Yeah, it says the host has stopped it.
Okay, that's probably me then. We'll tell you what, you introduce yourself now on voice, and we'll bring in the camera later on.
Yeah, sure. I mean, looking at the names, a lot of people will know my face, I'm sure, anyway. But yes, so I'm Cat Bell, formerly DEFRA Head of Marine Species Conservation, but finished that role at the end of May and have recently taken up Director of International Policy at I4. So I'm here today kind of as a in my independent capacity to try and give some insight on policy now that I've left government.
Cheers, Kat. And I think Kat will be great later on just to guide us through some of those discussions in that space specifically. Okay, and JP, if you can actually get on now, I'll see if you can introduce yourself as well.
I'm trying to turn my video on and it...
Yeah, video mode, I have to go in and play with the settings. So I'm going to do that in a bit.
Yeah, the host has stopped it. Good morning, everybody. JP Ruja from Bermuda. A little bit of a panic here because my wife and daughter have just called saying they've missed their flight in New York and I need to arrange a hotel for them. So I'll be a little bit distracted for the next few minutes. Yeah, I'm basically based in Bermuda, where we like to use Bermuda as a field station for testing and developing ocean technologies, and in particular hardening them in the last stages before they get released for general use. We have a full range of habitats here, all the way from mangroves to coral reefs to deep ocean, all within 30 minutes. We're an hour and 40 minutes from the east coast of the US and 6 hours from the UK, and makes us a really good spot with a quite sophisticated and robust infrastructure for developing tech. We're a day or two away via FedEx or UPS for spare parts from anywhere. People can fly in on as needed. The permitting here is quite flexible. Obviously, it's not just an open book for permitting, but the relevant authorities are quite responsive to appropriate applications, and we're generally able to get permission to do anything that is reasonable and worth doing from a science point of view.
Brilliant. Thanks, JP.
Thanks.
Great. So I'll have a look at actually getting their faces onto the screen later with video. But for now, we'll continue and we'll go into what is bycatch and why is it thought to occur. We'll have a look at some of those threats. Okay. So for anybody new to this space, which I hope there is, because the reason we're hosting this is to try and allow fresh blood, so to speak, to get involved in this very interesting development arena. We know, obviously, from the panelist list here and for the attendees that there are a lot of familiar faces, but I think there's a lot of opportunity to get engineers who have had a desire to work to do something for bycatch or the issues that we know marine species face, but don't know how to. Potentially, you've dabbled in open hardware, software, engineering, maybe policy, and you just want to learn more. But also, this session, I think, is a good chance for you to meet others and for us to go through what those barriers are preventing you from doing just that. So if we question what is bycatch? Well, bycatch is the accidental capture or entanglement of sensitive species that will lead to injury or death. This can include cetaceans, so whales, dolphins, porpoises, but it's also paramount for seabirds, seals, protected species of elasmobranchs, sharks, skates, and rays. And a typical photograph of an entangled whale is this one here. You'll see there are a number of very typical bycatch species, which often include entanglement with a fishing rope or fishing net. And that's because you can often see that quite visibly. It emotes a reason to want to interact and do something for that species. And a lot of the photographs you see that are, I suppose, driving attention or trying to fundraise, etc., often use motive species photos like this one on screen. And if we ask why bycatch happens, well, it's the accidental capture in fishing gear. And it's one of the greatest threats faced globally by cetaceans, and has contributed to the decline or extinction in some cases of local populations. And again, another typical photograph is this whale that's entangled in fishing gear. And it's that entanglement that can often cause a real challenge for mitigation, because once an animal is entangled, it's very difficult then to understand what that means in their life. So how long was that entanglement? How did it occur? How do we know that that animal is entangled? What do we do about it? Those are the questions that we hope to seek through mitigation techniques, and what we'll be talking about again later today. And interestingly, I took this graphic from the clean catch work that's done by Mindfully Wired, and a lot of the screenshots actually coming up are all from the clean catch reports that have been looking specifically in the UK at bycatch. And in this one, it illustrates the number and percentage of diagnosed bycatch cases among stranded cetaceans. So this is quite interesting because you obviously need the animal to be stranded to physically inspect and have a look at what that cause may have been. So it may have been something such as plastic ingress. It could have been hit by a propeller, by a boat. But in this case, you can look at common dolphin bycatch. The percentage there of diagnosed cases is a lot higher than harbour porpoise and even minke whales. So it also makes you think that bycatch mitigation doesn't always have to occur in the water. It can occur on land. It can occur by working with stranded cetaceans or stranded marine mammals that have already died and there's an inspection taking place. But it also opens up this, what does open science mean in that regard? So for me, there's a lot you can do on the beach versus always having to think you have to be in water when we're producing solutions. And if we look at this is a great chart, the risk of wildlife bycatch in the southwest of the UK. Again, this is Clean Catch that put this together. But if we look at this chart here, we can see that gill and trawl net fisheries are quite high up on the list due to the behavior of those two fisheries in terms of a gill net is suspended in water. And we know that entanglement is a real factor with gill net fishing. And of course, trawling comes into its own if you imagine accidental capture in trawl nets. But also pots that are used for lobster pots or the creel fisheries. We know that whale entanglement specifically is an issue there because there are rope systems connected to those pots with buoys on the surface that are designed to allow the pots to be recovered and also to know where they physically are in the water. And we believe that the rope system itself, and of course you can see this visually, is one of the leading tributaries towards why whales are caught and entangled. So if we look through some of these fisheries and start to think about what type of gear that we use in fisheries and what can we do about it, a great place to start is to go to cleancatchuk.com/hub. And there is a bycatch mitigation kind of WYSIWYG. What you see is what you get. So you can select a gear type. You can then go through to a species that you're interested to know about, and it will guide you through a kind of selection as to what are the options available to mitigate. So what can you do if you actually want to do something about it today? So is that a physical deterrent you can use? Is that some known science or some mitigation technique or a methodology? We'll go through a few of them in a moment. But I think this is a great place to start if you're new to this space, because you'll get a good understanding of what's already out there today, And if any of you on this call too, go to the site later and see that your own solutions aren't on there, get in touch with the team and they can add your own solutions, I'm sure, to this list. And of course, this is designed actually, not just to be in the UK, but to talk about bycatch mitigation options globally. And if you actually go through and filter down the list, you will see that it will come up with a selection of different mitigation techniques. And what will be interesting that you'll see are some are physical in that they are LEDs, for example, or they are pingers. So these are electronic devices that have been designed to do a very specific thing. So the pingers emit a sound at different frequencies depending on what you're targeting to alert marine mammals to the presence of nets. Passive acoustic deterrents, and we'll get into that shortly with the PARs. They're designed to be very simple in that there are no electronics involved, meaning that it can often be cheaper to implement, but also something you can introduce without the need to replace batteries or worry about water ingress. And even things like glow rope, decoys, and then methodologies, so technique changes. It's not always about physically making something. It can be about knowledge sharing as well and research. And that's why I think openness is quite interesting to think about when we talk about how do we release our research openly in a way where others can access it? How do we share knowledge in that space, as well as the typical area, which is sharing hardware designs or sharing electrical software, things like that. It's not always in that one space. There's a lot of openness that can come into working in bycatch mitigation. In a moment, we'll look at a truly open solution, which is the EGA Intelligent Buoy. It's designed to prevent gear loss and provide a solution to ropeless fishing. And ropeless fishing is when we take, for example, lobster pots, we try and invent ways where when they are deployed to the ocean floor, instead of having a rope system, which we know can be an issue for entangling cetaceans, they will drop to the floor and they'll be released acoustically, so by a ping or anything you want to send to it. And you can either float a rope up at that stage to see where it is, or you can even try and float equipment back to the surface. There's lots of good ropeless fishing intervention happening at the minute. And I think that's a good space too, to think where does open hardware and technique changes come into play. But also it's not all about open. Hook Pod, that you may have heard of, was actually launched on Kickstarter to give it a good start. It was successful. They raised £113,000. It's a really simple way of enclosing the point and barb of a fishing hook as it enters the water. So essentially it prevents that accidental catch, especially for albatrosses, etc., by making it impossible for the birds to become hooked until you get to a certain depth where the birds don't get to, and it opens up the hook at that point. Now, that's not open, but it's doing a fantastic job out there. There may be open techniques or sharing of data or successes that can still promote its use. We're definitely not saying that all we care about here is open hardware. It has to be open. I think there's a real interplay between what we can do in both of those spaces. And of course, later we'll get onto what the benefits are of openness in this arena and how potentially we could merge the two. And of course, there are some new novel solutions, Catch, Cam, Safety Net. They have a new camera system out, which allows you to record inside nets and your gear to better understand what you're catching. And I know that's multiple years of R&D and sweat and blood to get to that stage, but it's great to see these are becoming available on the market now as solutions moving forwards. And there's probably lots we can learn from looking at those video clips as to how we can potentially merge multiple deterrence or mitigation techniques together. So we have a look at the EGA V2. I really like this. It's a short little YouTube video, which I hope plays okay. Whenever you do these live webinars, you always find the videos never work. We'll give it a go. But you can see the technique here is that this is fully open, designed by a team of 5 people. And for me, there's a question here as to, we see a lot of great development like this that is done in, say, a hackathon between friends. It's promoted via some YouTube videos. It gets really good attention and it shows great promise, but it's very hard to take ideas that are kind of done in a more kind of, let's say, siloed way, in that it's done over a period of time with a team which happens to be in the same room at that point. But then it's hard to get this all the way through to in-water trials, someone to adopt it and someone to run with it for a long period of time. So if I play this little video here, start at the beginning, hopefully you can see this. There you go. So here you can see a demonstration of a device that I think really sets the scene by showing that they've managed to openly release a capsule, timed or potentially by acoustic release. And this is all open source. You can go to Hackster, you can get the files, you can download it, you can continue building upon their initial effort and work. And I think that's fantastic they achieved this. It then comes down to, how do we take an idea like this and actually build, let's say, the partnerships together to get this in water, to say, okay, we will pick this up as a solution. We will go and try it. We will see if we can get it into the hands of actual fishermen working in the sector. There's a lot to think about there. There's a lot of resource, time, commitment to do that. But at the same time, we've got a great demonstration of this solution. So thinking about what are those barriers to taking ideas that are conceptual and getting your hands on them, and potentially it's like needing the skills to do that. Like, do you need hardware support, software support to take this technical design? Well, you probably do, right? And then what do you need to get to the next stage? How do you go through all of that? We'll definitely talk about that later on. Okay, so now to help just summarize what some of the threats are. So we'll go through some of the key species and just have a look at what these threats are, because you may also join this webinar with your own ideas about mitigation techniques. So I think it may be useful just to kind of review this before we get to the next stage. But if we look at what the highest threats in terms of gear are for cetaceans, gill nets are high up on the list, trawling, bottom and mid-water, and sign nets, beach and purse. So these are the top contributors to accidental bycatch for cetaceans. We move on to threats for sharks. We then have longline fishing. Remember that hook pod that we saw in the bird space was trying to solve that by limiting when the actual catch can take place by having a depth sensor. So again, really interesting, simple, novel ways of saying in the bird space what you can do for longlining. Dredging is high up on the shark list. We have gill nets again. So it's 2 for gill nets now. And again, trawling, bottom and mid-water. Move into skates and rays. Again, gill net, dredging and trawling. So we have 3 interesting spaces there that are coming up a lot in terms of multiple bycatch incidents. And of course, longline in this case. The seabirds, longline has a lot of solutions now. I think there's been a lot of progress in that space. But once again, we have common gill net and trawl. But of course, we have the seine nets as well. So these are predominantly repeating themselves, the gill nets and trawling. Then we go into even leatherback turtles, and we have a mix of all 4 there. So you can see we're not dealing with, say, 10 different fishing gear types here. There are 2 or 3 that come up a lot in this space. And I think it begs the question as to, if we focus on those, can we achieve more together versus trying to be very prescriptive across the whole sector? And if we boil this down to say, well, okay, well, what are we doing specifically to monitor cetacean bycatch today? We look at these bubbles here. And again, these are all screenshots from the Clean Catch work. So thank you very much. I've stolen them all for today. Let's have a look at these bubbles here and have a look at what are we doing to monitor cetaceans and how that leads to bycatch mitigation. Well, we start up here in the Fisher data. This is still really important. So fisher-led self-reporting is the fishermen who are out there on the vessels. They're seeing it happen, literally in front of them. Getting their data across as to why that is happening, I think, is still imperative. So it may be that the interventions we make are still not just physical gear modifications or in-water interventions. It may be we working with the fishers in new ways. That could be through the development of new ways to engage with the fishermen, new ways for them to share data. And again, openness can play a big part there because there's a lot of open software development and so on that can happen from a landlocked location. You may be far from the sea, but you can still contribute towards helping in this space. We then have observer coverage. And again, for someone who's just watching today, who just wants to participate in this world, you're probably going to want to have access to look at this kind of data or to be aware of that data through peer-reviewed papers to know what's going on in that observer space. So obviously, you can't connect yourself to it directly, but there's probably great knowledge in that space that can help you understand what it is you can do. We can then go down to strandings data. So there's really great strandings data produced by the team over at the Zoological Society of London in the UK. We may have some international people attending today who will probably also be generating good strandings data that can help you, for example, look at drift models. And strandings data, of course, going back to assessing how bycatch happened is really important. So remember I said you can still play part on the beach. I think that's really true. You can work on the beach in interesting ways to look at, for example, the laceration types on the skin of stranded porpoises. Can you actually see from that data as to what the type of net was? I think you can in certain instances, especially if the body hasn't decomposed too much. But can we tell more from that? Is there more we can do in a non-invasive way that helps us understand what's going on in that space across fisheries, potentially in areas where budgets are of concern, where there isn't access to high-tech equipment? What can we do? So again, that's a really interesting space. Then we move across to sightings data. This is great because it really brings in the citizen science aspect of the world. I know there are loads of great surveys done from cliff tops where cetaceans are noted. Over in Wales at the Cardigan Bay Marine Wildlife Centre, there's a lot of great voluntary surveys done there. Satellite monitoring is very interesting now. We know for large cetaceans, it's possible. Obviously, the smaller you go, the more challenging it can be with remote sensing. But still, you can get information from AIS data on boat traffic. You know where boats have been fishing. You can link that to strandings data. And there's a lot you can do in that space again from a keyboard. So again, it's not just having to get to the sea. There's a world where we can explore both angles. And up in electronic monitoring, this is a really interesting space because I think this also kind of pulls the heartstrings on engineers who want to give back. So they see bycatch happening, it's emotive, they want to do something about it, and they ask the question, how do I get involved? Now that to me is really interesting because there aren't incredibly simple ways to just get involved. If I got an email today saying, hey, I want to help, I have to really think about where can I place that individual? What can I get them to do? And I think later on when we get into the Mentimeter, we can have a bit of a chat about what can we do to make that world easier? So if there are skilled engineers who are mechanical, software, hardware, etc., who want to participate, what is it we can do to make it easier for them so we can get more out of the work we do and hopefully reduce bycatch? So there's a lot in these bubbles, I think, as to what's going on today. And let's ask the question, what don't we know when we're monitoring bycatch? And this one has an unlimited number of what ifs. But let's just, for example, say, was the animal in distress for a short or long period of time? There's some fantastic work going on with hydrophones over at the Sea Mammal Research Unit, where they're looking at triangulating the animal using echolocation to get a 3D representational image of what happened with the animal in and around the net. Now that's starting to ask, for example, did that animal interact with a gill net and get caught for literally 5 minutes and then opportunistically the net was brought up? Was it there overnight? Did it become entangled quickly? Did it become entangled over a long time? Did it suffer? You know, these are questions that we really want to know to see what's going on beneath the water. And if you have to ask yourself, what can we do to understand that? Then we start prodding at things like the use of multiple hydrophones and locational data, or the use of cameras, which again can be challenging when you've got silty water and you've got visibility issues. Are there other sensors? Are there other ways of understanding what happened to the animal? And if we can tell that it was distressed, what can we do about it? Or can we, can we use that data to affect policy? So that's one question. How and why did the animal become entangled in the first instance? The ultimate question. Did it know the net was there and it was fishing around the net? We ask this with passive acoustic reflectors all the time. Are the reflectors telling cetaceans, hey, there's a net in the water, but that's also saying, hey, there are fish over here? But that's the question. Are we having an adverse effect as well as a good effect? We don't know. We're looking at that in terms of the research. So how can open science help us address that question? The next one, what's actually working below the water? So when we put our mitigation techniques in, how effective are they over time? Because the only way we're really going to tell is if we have a good scientific study over a good period of time saying, have we had a positive effect? Have we compared a treatment net to a non-treatment net, for example, to say, well, in this space, this has had an effect or not? That can take a long time. And I know there's a lot of people on the call who will be realizing that that can take years. And to even prove it substantially is very hard. So can we work better together in this arena? Can we share data? Can we use openness? Can we do something about that question? And then moving on, can we improve our understanding of bycatch in new ways? So are there things we haven't thought about yet? Obviously there are. There's so much more to do. But can we improve our understanding by potentially creating new partnerships? Can we improve our understanding by sharing data that potentially was once unshared, specifically to help somebody who has asked for it to do something new? These are the questions when we get into openness that we will debate shortly. And again, why exactly are whales so awesome? Now, we already asked that earlier, and we have to ask it again. There's a lot to unpack into why that is. So have a think about that one, because we're going to actually ask that question later on, just to make sure that we unpack it between ourselves. Okay, so we'll now jump into a quick case study. It's not a long case study, because I want to try and make sure we get plenty of time in this session to get to the Mentimeter and for you to have your own say. But in this one, I'm just going to have a look at a project that Arribada worked on with CFAS and DEFRA to produce passive acoustic reflectors. And the reason this case study is in here is to give you a sense of what we had to go through to develop this solution. And I think that will help us answer the questions moving forwards as to how we enhance that space and make it even better for others to replicate. So our objective was to identify and design a viable passive acoustic reflector to increase the visibility of gill nets for cetaceans. And we wanted to co-design this with fishermen, so asking for their opinion on, would you actually fit this to a headline rope? Asking for their opinion on how much would you want to actually pay for this if it existed in real life? And all those kind of questions that come into the reality of fishing every day. Is it going to fit into your everyday routine? Do you have to change your fishing practice to use this? Is it too big? Is it too small? All those basic questions that we thought we needed to know. And we wanted to make sure that this is actually affordable to manufacture. I think there are some fantastic designs that come out, but then it becomes very difficult because it's just not cost effective to roll out at scale. And the scale we're always talking about here needs to be many, many nets over many different fisheries. So when we started this, we had to look at what the reflector is going to do. So we had to look at that target range. Our range was 100, 130 kilohertz. So we were in that porpoise dolphin space. And we spent the first few months on this project just looking at the data out there. So going through the papers, looking at how a reflector would even work. Is it going to be specular? Is it going to be diffuse reflection? Where is that energy when an animal is echolocating? Where could we direct sound back from the reflector to the animal, and how could we do that in the most effective way? So a lot of our time was just sat there researching. And as we know, research takes time, it takes funding, it takes resource, it takes knowledge sharing. And it's one initial barrier as to how can we keep on sharing knowledge that we find when we develop these mitigation techniques, so others that come after us to work in this regard can get straight to from A to Y, not to Z, because we're always trying to get there, but A to Y to say, well, we know all this, we just have to solve this, instead of trying to replicate this each time. And we went and looked at past research. And when I first started working on this project, I went down to Loughborough University, and we'll get onto a few slides in a minute as to why, because they had a test tank, so we could actually test old reflector designs that others had tried in the past to see how effective they were. And there was this old metal cupboard in the corner of the room, and the professor there said, hey, you know, someone actually tried this quite a few years ago. You should have a look in this cupboard. We opened this cupboard, like quite rusty doors, and inside there were like shelves. On each shelf there was a little replica prototype. There were some made of metal, there were some spherical, there were some that looked very similar to this design here, some that were steel, some that were aluminium, some plastic, and they were made in 1995. And they were sitting in this cupboard, and they were still there to this day with like notes written and sketches. And I thought, some poor soul has spent many, many years trying this all those years ago. And I've turned up and I'm trying to replicate it from scratch. So already you've got this kind of knowledge sharing scenario there, where how can I tap into the knowledge that that person created? What did they learn from all of those assets? And yes, we can share it through papers, and yes, we can share it in that traditional way, but also in the Bycatch space, what more can we do in the open world to make sure that we can step forwards and share as much as possible to advance our development of these solutions? But what we did is we looked at the shapes and designs of existing reflectors, and we started to play around with, I would say, very R&D based designs, just to see what we would get. And in fact, our first design, which was very unsuitable, but it was our first design, was this very interesting looking device up here, which was essentially designed to reflect at multiple angles. It was designed to be very small to fit onto a headline rope. We were playing with different thicknesses of material to look at the resonant value of it. We were looking at the strength, and we soon realized that this would be smashed to bits when it went through a flaker. So we took a photo of this just to show you what we first prototyped up, and then very quickly realized it would never actually work because it would just be too weak as an object. We started playing around with the design. We then started to test all these different designs at the facility at Loughborough University in the Wolfson School of Mechanical, Electrical and Manufacturing and Engineering. And the reason we had to go here was so we could actually quantify what that value, how well was that reflecting as a passive acoustic float, essentially. And remember, it was doing two jobs. It was being a float and it was reflecting. So we had to come up with a methodology where we could repeat tests. And we wanted to know, well, what do traditional floats reflect like? What do all these spherical floats here? Some are single air cavities, some are made of roto-molded closed cell foam, like these blue ones here. This is a T80. So these are traditional floats. Then we realized that not all fishermen use the same floats. So some are using different weights, floats, gear. It's got this whole mishmash of, well, how do you produce something which is universally going to be accepted and do the job? So we started to test the reflectance of every single float, started to produce a report. We came up with some methods where we would dunk our floats in this test pool, and we would use a hydrophone and a recording on a National Instruments 6363 for any geeks in the room. And we would look at the reflectance at all the different angles of the different floats, and we would introduce our reflectors and then work through systematically and modifying the thickness, the dimensions, all up to the point where when fishermen had said to us, that's too big. So we never went over that step, just to see where we could get. And we played around with all different ideas, specular, diffuse, different material compositions. And in the end, we didn't even use this spherical design. We actually went through and ended up using a design like this. And it took us about 2 years just to get to this point. Govern it was through COVID at the time, but still about 2 years to get to this point. And at each stage of that, we were modifying, we were asking for knowledge from specific companies. We were always thinking there's got to be a material specialist out there who knows that the closed cell properties of HD115 is the best in terms of reflectance and hopefully not too much absorbance of sound. We were looking for where the sweet spots were between a float that can float, reflectance in terms of bouncing energy back to the target, cost, size, and everything else. And there are a number of questions that get asked. And all the way through, we were also thinking there's so much knowledge that if we had it in front of us today, or we had access to it, we could have done this in a quicker space of time. And that beckons the question too, that if we start to work collaboratively together, maybe even we have 20% time shared from some industry players and like corporate companies that do this, but work on more kind of specialized high budget solutions. Maybe 20% of their time may help us ask those questions and save development, be quicker, be more agile, and share on that knowledge further. And if you conclude this, well, research can take a considerable amount of time, a real considerable amount of time. So it's hard to get funding to do that. To say, can you pay for time for 2 or 3 PIs to work on something for 3 years is a lot of money, and it can slow down and stagnate what we can do in this space. And many have tried before us. Like I said, the 1995 experiments that were in that cupboard, if I could have accessed their notes, which were not particularly easy to find, there was only one paper on what they found, and that didn't really go into the materials. It was more about the outcome. Potentially, we could have moved forward quicker. So what can we do today to make sure that as much of that knowledge is shared? Potentially the CAD designs, the shapes of what we've produced, the methodology, the materials, the cost list, where we bought it from, all of that can be packaged in to say, please take this knowledge and let's go forwards together. And of course, how do we ensure that our efforts and results can be best utilized by others in the future to advance our research? Now, this steps into, well, if it's commercial, you don't want to share it, how do you go about that? Well, I think there are bits and bobs we can dive into in a minute in the Mentimeter to make sure we can share, but still be, for people to turn these into viable, commercially viable options. That's what we're trying to get to. We want to ensure that can happen, but also what can we share to make sure we can do more in the Bycatch space? And if we look at barriers, well, we had access to this amazing test facility here where we built our methodology. We could go over to Loughborough and work with the team there, and we had access to 20,000–30,000 pounds of equipment to pull this off. It helps to have access to the ocean as well. Even though we are here testing this, if you're landlocked and you want to give back, sure, you can do a lot in research facilities, but knowing it works in the ocean, that it's not going to degrade over time, that your material isn't going to biofoul and essentially stop doing what it's going to do, is challenging. Not everyone has access to the ocean. Getting equipment in the sea onto nets needs relationships. It needs funding. It needs policy to say you're allowed to do it. So that's one key barrier. We can ensure we can improve access to the ocean, maybe by allowing others to test their equipment alongside our equipment. Maybe that's one barrier we can unpack. And then replicating cetacean echolocation in a test environment isn't straightforward. You've got reflectance from the walls of a tank. You've got to work with those parameters to know what you're actually recording is the viable target. You need someone who's been there before to show you the methods of how to do that correctly and not have to reinvent the wheel each time. So it's sharing those methodologies. And again, the tools and hardware we had to do this is not available to everybody. So what can we do to say, well, here's a cheap way of recreating this. Here's a low cost budget way of reproducing this research. So there's a lot probably in that open space we can get into. But that is enough of me talking. I've been talking far too long, so we want to get other people involved in the talk. So what we're going to try and do now is we are going to start our Mentimeter. And the way this works is you'll have to potentially right-align your Zoom on your screen and left-align a web browser, or just Alt-Tab between them. But if you go to menti.com, there's the URL there, you type in the code 5494 4640, you should get questions appear. Now I'm going to share my screen to allow us to see those questions. We're going to go through those questions together, and I'm going to open it up for Kat and JP to join us to talk about those in a moment. And we'll also have Nigel Butcher from RSPB, who will be joining us in a short while too. So he'll join us in that session. But first of all, I just want to make sure you can all get to menti.com and you can see those questions. And we're going to go through those together. So let me now share Menti and get that working for you. That'll be one moment achieving this. Okay. Oh, I can see some of you already in there, so that's great. Let me now reshare my screen. Okay. So you should see on the screen now, which sector do you work in? And you can see it's live. So I really like this because it gives us an idea in a minute when we get to word clouds of what's going on. I can see it's quite interesting if there's a weighting there towards NGOs and charities, which is good to see. And we can see it's academia next, right? So we're in that academic charity space. Oh, someone else has joined us. Okay, so I'm going to advance to the next slide. And again, you can fill in these slides at any point in time. You can navigate forwards and fill them in and go ahead. But what we're going to do is we're going to go to the next slide or the next question. I'm going to spend 5 to 10 minutes on each one, and they're word cloud questions. So we're going to unpack them together. So for example, once you've finished that first slide, the next one asks you, what motivated you to join Making Waves today? So this one I think is a good one to unpack because we really want to know why you spent the time to join us today. And if you write a reply, the kind of responses that would come up on the screen, maybe, for example, you want to understand what you can do to help mitigate bycatch. Or maybe you're an engineer and you want to work on a solution. There we go. So open science, open source, and conservation tech are coming up. We have knowledge, action, nosy. Good one. And by the way, nobody swear or write any swear words because it'll be a nightmare editing this out in the video later on. Can you only imagine? Conservation. I think that is actually one of the real reasons, because when you're out there looking for a solution, you want to get involved in this space, and you look at bycatch as a problem, it's very visual, very emotive. Let me bring in, I'm going to bring Kat and JP in. I'm going to ask to unmute you both. Let me know that you can get in. I haven't figured out how to turn your videos on yet, even though I'm supposed to be the tech guy, but we can use your voice.
Right.
Yeah. So, Kat, as someone involved in policy, who's been in this space for a long time, what would you say was your motivation to get involved in marine species? And what was your motivation to end up in that kind of marine species, bycatch space?
I mean, my motivation, I suppose, at the time was driven by ministerial priorities, which is slightly different as to how it's kind of progressed. Obviously, there's a lot of people in this field who are doing a lot of work. And I think one of the things that I'm still quite institutionalized. It's not we anymore. One of the things DEFRA wanted to do was to kind of try and open the collaboration side of things and try and share some of that knowledge. And I think that is like a really important part, because there's a lot of knowledge on this. There's a lot of people that have been working on this for decades, and it's really trying to tap into that, which I think is what this is hopefully really helpful at doing as well. Yeah,
brilliant. And JP, we'll get into you later on, but you have created Station B, which is specifically designed to allow people to test ocean tech cost effectively in deep water and easily. So you've obviously been motivated to do something in this space. What was behind that? Why did you want to do that in the first instance?
The main thing is we just wanted to remove the barriers for doing so, because there's many of you who are doing great work in places where you just simply don't have access to the deep ocean in particular for testing things. And the alternatives are just not that great. If you're on the East Coast, you tend to go down to field stations in South America, or you go up to Halifax, or where the weather isn't great. And in South America, you just have logistic issues with getting things in and out of the country, et cetera. And Bermuda logistically, I mean, what we've done is Bermuda is frankly the highest cost of living in the world, one of the most expensive places in the world to do anything, but we've removed those barriers. We've set up an NGO, and we're working with customs and immigration to remove the otherwise expensive cost to dealing with Bermuda, to make it so that it will be as cost effective for you as possible, and equivalent to, or if not less expensive than other places. One of the sweet spots we find is where we were set up to replace some of the testing that gets done on these big US NOAA type vessels, which is needed in the East Coast to get off the continental shelf. So we're replacing ship-based testing. And we're definitely, in those paradigms, we're far, far more cost effective than chartering a vessel for 2 days just to reach deep water. It's more cost effective for somebody to send their equipment and fly to Bermuda than it is for them to charter a vessel and reach deep water.
Yeah. Yeah, fantastic. We'll touch more on that later on as we move forwards too, because you can look, if you look at motivation on the screen here, the larger the word, the more people talked about it. So conservation, open science, open source, and technology. And technology is still quite paramount there, but also curiosity. So I think there is a lot of interest in what's happening in this space. And as we get into these Mentimeter questions, one of the benefits of today, as one of our first webinars in this space, is to try and unpack and understand what can we do in this space? What are those benefits of working openly? And all of this is recorded, by the way, so we will share this and use this in a document too that we'll produce. But if I actually go on to the next slide now, and we ask the question, in your view, and this will be different for everybody who's attending today, but in your view, what would you say are the main barriers to researching and developing bycatch mitigation solutions? The reason we've asked this question is there may be very specific ones in academia. There we go, complexity coordination. There may be specific barriers in industry. Potentially, you don't know what is wanted at a policy level. You don't know what fishermen want. You don't know what's working. Where do you go to get that information? So I'd love for everybody to kind of input on this one as to what you think the main barriers are to researching and developing mitigation solutions. And also joining us now, we do have Nigel Butcher, who is from the RSPB, who Arribada works with closely on a lot of technical developments. Nigel, I'm going to allow you to speak by pressing Ask to unmute. If you have access, you're welcome to introduce yourself.
Hi there. I'm Nigel Butcher. I work for the RSPB as Senior Technical Officer, and when the RSPB created my role in about the 90s, I'm very forward thinking because there's not much in the conservation tech sector that they considered the kind of requirement for resource to be provided for that domain. So it's very specialist, and yeah, my bycatch issues for birds are slightly different to where owls come from and the cetaceans and things. So it's the kind of, yeah, the knowledge base and the requirement that no size fits all. And in my 20 years or so at the RSPB, I've realized that you need to spend kind of lots of time and share lots of knowledge, because nothing kind of does every job that you want it to do.
Yeah, absolutely. And I think we both work, Nigel and I both work in the development, for example, telemetry tags and other devices. And when you try and replicate technology in the ocean, it's really hard, in that the ocean eats things. It destroys things, the salt water, the pressure, the biofouling. If you look at some of those tags that are developed for tracking seabirds, then they are robust, but to a degree. If you're in the sea all the time on fishing vessels and you're getting hit by flakers when nets come in, you've got years and years of life ahead of you. all of those harsh environments. To develop solutions that are robust and can really survive in the ocean is also a real challenge. It's something that takes a lot of R&D, I feel, to get right. And it's something else that we have to think about. But on the screen here, funding, really high up on the agenda, as we all know. Deriving funding is massively important in the open space too. And the coordination, I think, is key, because if you look at how the passive acoustic reflectors came into play, that was part of DEFRA's mandate to say they wanted to do something about reflectivity on fishing nets to make them more visible to reduce bycatch. So that money is coming from that policy level and from the government departments to say, we want to actively do something about bycatch. And we were able to work with DEFRA and CFAS to develop that. So on our side. Now, if you come from just an open background and you want to get involved in this space, getting into that world isn't probably so easy, because you either have to be known for services that you do, you have to know somebody within already working in that space and come in as like an employee or somebody connected. And you can see, if we go back to that video I shared of the interesting ropeless fishing solution. How do we take something like that, which is obviously working, it's demonstrated, but get it into a world where you can fund it and take it forward? It's like, how do you meet a team like that, which was 5 or 6 people working remotely, and translate that into something you can get into the ocean if you want to test it? Who picks that up? Is it picked up by engineering NGOs who say, oh, we'll take it forward, we want to help you? Or do we create some new ways of picking it up? I think there's questions there. JP, for you, who, again, you test hardware, if somebody approached you and said, I've got something that I want to try, like the ropeless fishing gear, they wanted to say, we want to test it at, 100 meters to check that it's pressure proof down to that level. What would you first need to do? Would you be restricted in the same way that it would instantly hit funding as the barrier? Or would you say, well, let's co-write a grant together? What would you do if someone approaches saying they don't have the resource, but they've got a great prototype? What would your advice be to them?
The immediate, is there an obvious grant that this fits under? I mean, if there's, look for the low-hanging fruit of funding opportunities. It might be that there's a real obvious one out there that this fits with, and then go for that right up front. If there isn't, you might need to find other ways to get it going while you're chasing the funding. We unfortunately tend to just move on things while we're waiting for funding, which isn't always a good idea. But just doing anything on the water is expensive. Just fuel, just to get out to deploy something, is in the hundreds of dollars a day. So it's not, even if you had the asset that you just want to get overboard, physically getting it overboard costs money. So it's not there's no easy way to do it cheap, let's put it that way. So
yeah, exactly. It's a key barrier, right? Because it's always limiting to that point of view. However, because there are interests from certain players to develop solutions, we could see that there are some popular solutions that were kind of self-funded because they, for example, like the hook pod that went forwards and did a Kickstarter just to get it commercialized. Do you see any barriers to open being an issue there? So, for example, do you see people approach you saying, hey, I've got an open source idea. I don't have a commercial idea for it, but I want to share it forwards. I want to give it to people to use. Do you see that happen a lot? Or is it more, I've got an idea and I think it could be, it has commercial legs? Does that ever happen?
It tends to be more the other way around. I mean, it's 2 tracks. Well, there's 2 different types of funding, I guess. There's, if it has a commercial commercial angle to it, then you could get investors versus funders versus grants, right? And people are more likely to bootstrap it and get it going if they think there's a commercial opportunity down the line. If it is going to be open source and it's the costs aren't any less to develop it, it's just it's a different track for the funding. The people who are doing the open source tend to come to us with they've already got some baseline support for their efforts.
Yeah,
or
absolutely.
after a specific grant. You have to be more, you actually be more focused on your funding sources when it is open source, because they're not as easy to find, I guess. Is the way to put it.
Yeah, well, coordination's right up there. This is
Yeah.
why I think these word clouds are really interesting, because we've got coordination, funding, and policy. If you merge those three together, it could be that, for example, one thing that's always kind of in the back of my mind is when an organization such as Arribada is working and in a you know, luckily in a good position to be able to go forwards and try these passive acoustic reflectors, can we alongside it reduce the funding barrier to test another let's say mitigation technology alongside it, because we're going to be in the water and, you know, we have a team who's able to be there. Can others do that? Can others who have their own partnerships, maybe it's EU funding, maybe it's like an academic long-term project, can we coordinate and be even better at saying, well, we're going to have access to this vessel, and we know vessel costs are huge, as you said, right? Can we do it in a way where if there's enhanced coordination, there are, I don't know, let's say periods across a year where you can say, if you've got anything you want to test, we'll put it in the water, we'll run it for X time, we'll pull it out, and you can have the device back and get data off it. Just that is saving costs, but it's a big question.
And that we've just actually, I don't have the permission to say who they are yet, but we've just run a couple expeditions this year where the group that booked us for the expeditions and did the primary funding had the funding in place to pay for the vessel time. But once they had it and they didn't need the vessel all day long, then another project came on board at the same time that was open source. It didn't have the same levels of funding, but the ship time was already covered. So I'm all for, you know, leveraging those opportunities when possible. The challenges on the open ocean is you've got a big expensive device that you have to pay attention to. You can't drop everything for project B or C or D. You know, you have to be very careful about that those projects can work alongside each other, that you need to, you know, you've got a few $100,000 device drifting around. I'm thinking this is more on the bigger research side of things, that it can be hard to coordinate multiple things if they have to be done at the same time and you're not quite sure on the schedule of what you need to do.
Absolutely.
But theoretically, yes, it would be awesome to be able to say, I'd love to be able to say we have, and we should all talk about this, that let's say that 4 times a year, we've got 2 weeks of ship time. Who wants to come?
Yeah.
You know? And maybe we chase, that might be something that we chase the funding for the deployment and the facility costs up front, and then let people apply to come and join. And that would be, I'd love to support something like that if other people think that's worth doing.
Yeah, it may be. These are the kind of ideas I wanted to try and get out from this webinar too, in that it's kind of imagine if scenarios. We'll go into a few of them later on, but imagine if we together made that quite regular, and that maybe even once a year, but it was known. So when you're writing grants in this space and you're developing ocean tech, you know that you can say, oh, we will benefit from the once a year opportunity to test in this regard. And there's like, let's just say, a much more cost-effective way of doing that. You can bring in to all of the kind of grants we all write collectively to say, I'll be able to get it in the water in this much more cost-effective way because we know this exists. And if it doesn't exist today, can we make it exist? So just opportunities to be able to collectively try ideas out and even write it in as potentially, you know, a match towards what you're doing. But we've been on this slide for a while now, so I'm going to progress to the next slide. And again, we will take all of these word cloud submissions, because they're all great, and we'll turn this into a mini report at the end of the webinar series, just to show what we got through. So none of this will be lost, but it's great to see coordination, funding, and policy in there. So the next one is, in your view, what are the advantages and or disadvantages to working openly? Now, this one, I really want you to have a think about, because there are disadvantages and advantages, especially in our case, because there's an understanding between where do the lines cross in exactly different priorities. Where do the lines cross between developing a solution that has, let's just say, closed source hardware, software code, whatever, because it's of commercial interest. And that means that it will be successful because there is a commercial backer who wants to release something specific to solve bycatch. And let's say it's very successful at solving bycatch. That's a good thing, right? We don't have to say, well, it has to be open. On the other side, we've got openness, saying, well, it's great if we can share all of that effort and cost and research openly and let it be used commercially. And that maybe come down to licensing, because there are very interesting licenses that say you can take this and go and be commercial, but you have to pay it on. Share-alike licenses like GPL or CERN, those licenses that say that. So I'm going to open this one to Nigel, because Nigel and I work a lot in the kind of open hardware space. But Nigel, what would you say are those advantages and or disadvantages to working openly in your view?
So yeah, I mean, currently we've got a Seabird tag project going on, and there's people on the team. So some of them are very much about open sourcing and wanting to kind of research output, and papers are their incentives, and will participate in the project just for those benefits. But we've got others that kind of seeing it as a financial and it's part of their business, really. It's a financial gain through developing the thing, and the open source barriers then does cause concern. So you need to kind of make sure all of that stuff is written down and there's clear clarity when you start, because we have a project that's clearly, people have got different agendas. So one design will, one person who's involved clearly is quite happy for open source to be used, and we paper output and the better for the conservation good. But others that have obviously got financial interests as a startup company, it's their motivation to look financially on the topic. So I think that the key thing is making sure everybody's on the same page to start with, and you get all that paperwork, all your contracts are clear of what you're doing, and even then it can come back. You'll come back and haunt you. Somebody's come back and wanted clarity afterwards. So I think it's a tricky one, but I think you can get around it if you're clear in the first place.
I think that's really interesting. And also going back to the differing priorities, that popped up first there. Kat Bell, if I was to ask you from when you worked at DEFRA, was openness or the sharing of research openly something that was always seen a benefit? Was it always given a +1 when it was written in as ways to work forwards, essentially public money spent on that? Or was it never really a direct priorities? Really what you're looking for is it going to be successful? Interested to know if openness in any way there had a particular merit or not.
I mean, it didn't on principle. I think it was something that as a team they were very interested in kind of having it open source because of how that can support kind of areas and countries that don't necessarily have as much funding as we do to kind of put into development of these kind of technologies. So that was certainly something that was kind of thought about. But I mean, I think one of the kind of challenges around the priorities is that and Nigel's kind of touched on this, which is the whole what species, it's people have a pet species. And I think that's always quite difficult because that will often drive people in very different ways. And then you've kind of got for government funding, commercial element was never really a factor because we're never looking to make profit from it. We're looking at as to whether or not it's successful, right? And so I think that element was always was more straightforward, at least in terms of open working, but not necessarily data.
Yeah.
Bycatch data is also a difficult one in terms of working openly. I think that's a challenge.
Yeah, in terms of the sharing of that data.
Yeah, and the kind of I mean, I know that there are a couple of people on the call that have struggled to kind of get some data from the Bycatch monitoring program in the UK, and that's difficult because of GDPR and anonymizing kind of where the data is coming from, but also that's then a real barrier to being able to work openly and to kind of progress quicker. So yeah, so I think that there are also the kind of legislative challenges. I guess GDPR is a real a real challenge to data sharing.
Yeah, it's interesting as knowledge sharing has come up here, but it defines what is the knowledge. So is the knowledge sharing how to be successful in let's say manufacturing the solution, or how to be successful in demonstrating the method works? But that's why there's a lot in it, right? It's not just one thread of knowledge. There's like other issues such as the sensitivity around who's producing, or who is not producing, but who is, or in which sector, in which area is Bycatch higher than in other places, right? Because you get into the sensitivity of saying, well, we share all this data. Is it going to point fingers at particular fisheries, and how do you do that in a way which is, let's say, well governed, so you know that you're reacting in the right way and the data is viable, and it's not, you know, someone said there, like a bad actor can't reverse it. So there's a lot in that space. I do agree, and I think for me too, because differing priorities is actually potentially the biggest word on the screen there. I think it's slightly bigger than collaboration, maybe similar. Maybe it's about saying, well, we can be open in this regard, i.e. we can share, let's say, a technology. So we can say, here's how you can create a really low cost pinger, and here's how you can reproduce it. And we know that it's more challenging to be, you know, to access, let's say, data on strandings or something like that, for example, but we can still have an impact and a dent if we say, well, we can make pingers really affordable by sharing something that is, we can share in an active way. So maybe it's something like defining and prioritizing where in the open space we can have a dent, basically. And the big one is that avoiding duplication. Like, how can we say, take this, go forwards, and if you want to turn it into something good, if you want to go and commercialize it and it's going to be great and used, go for it in this way with the good licensing behind it, to say, once you are successful, if someone else wants to benefit from this, please share it on. Something like that, where we just be a bit more prescriptive in maybe a paper or something that says, here's how you can work openly in this space for good, something like that. Maybe that's where it's at. But there's a lot in it. All right, I think we'll move on to the next question. This one is, what actions could we take to make it easier for people to contribute to developing bycatch mitigation solutions? So this comes back to that original question that we had earlier, when if someone was to blindly email any of us today saying, oh, I watched this webinar and they were talking about what you can do, what is it we can do? So training, engagement, training is going to come up in a minute, actually. I think it's a real key question, because training also takes resource. How do we fund the resource? Because it's better to train people to get involved than it is to try and just take on random individuals who have said, hey, I'm an engineer, I want to help. Should we say it's better for us to try and help them, but also produce the training opportunities to say, well, you should go to this workshop because you and 10 others will all train together and we can share knowledge and be a lot more efficient in how we do it? Nigel, I know this is a big one for you. I'm gonna pull you out here.
Yeah. But
you've got views, and to give you a hint, the next question may mention the word apprenticeship, just to give you a heads up.
right, okay.
But training for you, you've got views on this, because you know it's hard to achieve, but you want to achieve it, is my view, right? How would you describe it?
Yeah, so I mean, yeah, it's one that's kind of hot potato for me at the moment, because obviously conservation money, and especially charity sector salaries, aren't what you'd want in the kind of in the kind of industry and on the high street. So you do it generally for the love in the kind of charity sector. So I had a colleague kind of go, and we had some money to advertise a job, and obviously didn't get that much uptake, and that just made me think, how could we do it? How I'm obviously getting towards the end of my career, and the guy looked at the demographic in the room, and I thought we would need new blood and new initiatives to kind of improve and get people in through the door, because it is a very specialized sector, the conservation technology zone. So yeah, I've been exploring with our kind of training people options for kind of apprenticeships. I mean, unfortunately, kind of approved apprenticeship schemes kind of take a couple of years to reach fruition. It doesn't sort the immediate problem, but yeah, there's kind of space to do these sort of things. And if we can get organizations together like Arribada and others, where they can kind of work with a day or so a week, learn all these different skill sets, because yeah, my domain's generally birds, but I do mammals, but yeah, there's all this other stuff that we could be doing, getting people involved in a training program, and then getting funding bids in that kind of consider this thing. Why can't we have a long-term goal of actually getting people in and a rolling apprenticeship program where we can get more and more people that are kind of keen to do conservation tech and open sourcey stuff, not for profit, just kind of getting new people in and new ideas. So yeah, it's something I'm really keen on, and I'm kind of looking at options at the moment. And yeah, obviously other people that would be interested in kind of taking people a day or so and adding their knowledge, because it's much more difficult to progress in this kind of hybrid working world that we're in. I had a traineeship when I was a youngster, and I kind of went through that, and I was in the office 4 days a week and did block vocational training. So yeah, I think it's something we should really, as a kind of conservation tech sector, should be looking at.
Yeah, absolutely. If you have a look at what's happening on the screen here too, we've got accessibility, networks, and funding is up there again, because obviously everyone's quite right. How do you facilitate the training? So looking at that question we had earlier, when funding came up as to one of the key barriers to just making, mitigation techniques, developing solutions, funding was key. We have funding here in training too. So maybe there's an ability here to say, well, it's kind of like 50-50 in both realms. But if we can produce the environment or create the environment where we can offer training, that will help us to de-risk the development of solutions, because we can bring in fresh blood, so to speak, of engineers and people interested in wanting to work on solutions. And not just engineers, but like, junior policymakers, people who are interested in from NGO and project management who just want to get involved. Maybe it's about, well, we've got a project manager who can give 20% of their time to help facilitate training. We've got a senior engineer who can do 20% of his time to be in the training workshop. But we have some way of trying to move forwards and offer this as an incentive to say, well, if we facilitate it, maybe we'll get continued evolution. Because at the end of the day, the reason we're even doing this workshop is to say, can we make a dent in bycatch mitigation through openness, through open solutions? And I think if I was invited to a training workshop and they said everything you're going to do in here is going to be openly shared, it de-risks the fact that whatever I learn, whatever I get my hands on, I'm going to be able to use and go forwards. Even if I'm taking it back from my own commercial offering, it doesn't matter, because I'm learning and I'm being able to be progressive and share back. And that would be the remit on the day. JP, hopefully you still have access there. We've talked about training over in like Bermuda, for example, too, or facilities to do it. In reality, what do you think it would physically take to have like a training workshop in Bermuda? Let's just imagine for a minute you can get people there and that's funded, which again, I know is always a dream, but let's say that's done. What would you want to see there? Like, what kind of support would you need on the ground? Would you be able to have access to vessels? Would you have to have, again, funding to hire boats? Would you, in a dream world, you'd need your own vessel and a workshop, but what would it look like to you?
Accommodation, convenient accommodations so everybody's near the water, just logistically. Vessel time paid for, so we don't need to worry about that. And building local capacity in parallel to everybody's flying in. So we don't want to just have everybody flying in and learning. We want to be building local capacity at the same time will be a key thing. And support from, it depends what it is you're wanting to train on, but support from the manufacturers or people like yourself to come down who are the experts in what it is that you're training, for them to be on site as well.
Yeah, it could be very prescriptive. It could be we are doing a passive acoustic training session for everyone interested in this space, but it's a mix of engineers, practitioners, researchers.
Yeah.
However, it's done in an open way, so we're allowed to share, or you know, not allowed to share, but we want to share knowledge openly to go forwards.
And if you're addressing a specific challenge, then if it's all built around that, then you could bring, you know, a variety of people and tools together. Again, to make the most of the resources that we have here, maybe layer on multiple efforts that are targeting the same cause at the same time. Could be getting more people and more brains around common goals. Could be very interesting.
Yeah, absolutely. And I think like the term parachute science, it's definitely not the best idea to just fly people in, do your training. It's 100% right. It's all about the capacity to go in, share knowledge about a certain deployment, bring in some hardware you want to test, but then have it stay in the water, be cared for to the degree that it's coming out, you're checking data, etc., and then give it to the hands of others, because obviously you're not in a space in Bermuda doing like large scale bycatch mitigation testing. You're doing the initial stage of what can you do in the water. Then it's getting it into the hands of the fishermen, the practitioners, the fisheries groups that want to use it,
and get the fishermen involved at this stage as well. So you know, so have on that end. But the key part is also, once you're here and it's working, then keep it here and keep it getting hard. You need to harden it. So you need to get it to a point that when it finally goes out to the end user, that it's more bulletproof. You know, you can, you know, rinse, you know, iterate the final versions of something here is what we're very good for. Just, you know, use it, break it, fix it, use it, break it, fix it, use it, break it, fix it till it doesn't break anymore.
Yeah, which we know is the best way of making sure it's going to work, and it takes time to do. But great to see this too. Again, this screen is populated again with funding as key, but then accessibility, communication. Communication came up on the last question too, so it's good. We're getting some key words here that we can take forwards to talk more about in the future.
Just policies and another thing too, that, you know, well, especially if we're here in Bermuda, we're UK overseas territory, so we're dealing with the same policies and the same legislative stuff as you are, but depending where people are coming from, there may be different considerations as well. So getting some background on that, I'm not sure where that fits in all your slides, but it's just a thought.
Well, absolutely. I'll move to the next one, so I think we can actually touch on that. Yes, this one. So I actually created this one specifically for Nigel, because we've talked about this as to what it would look like. But moving forwards with this, if for example, this is a posed question, everyone, if an apprenticeship scheme was established, and it could be anywhere internationally, let's say it was an apprenticeship scheme, what should the scheme focus on? So this is a big question, because I'm always too biased towards, oh, well, it will be an apprenticeship scheme for engineers, and we'd have, you know, great electrical engineering happening, and it will be in a fully fitted lab. That's the world that I live in, but it may not be the best place to establish or to focus on. It may be, policy. There we go. It may be that actually we can have an apprenticeship scheme where we have somebody who is interested in looking at policy, but also is a dab hand in the kind of technical space, engineering. So they can kind of, you know, an apprenticeship scheme here I'm talking about is an individual. It's not like it's one person coming into a scheme. Should we have an apprenticeship scheme where we can say there's one space for somebody in engineering, there's one space in policy, and there's one in communication? And we have someone who's a graphic designer come in, or a science communicator, and we say, you're now going to sit with the engineers to really understand how to communicate this, but it's an apprenticeship scheme. And these are the kind of things that in the open space we could do quite well, because there's a lot you can do when you mix together those different disciplines. On a screen here, network building, yeah, science communication, I think is still hugely key, especially if you want to attract attention to your solution. If you can't communicate what it's doing, then it will never get to where it needs to get. So question for you, Kat, someone who's spent a lot of time in policy, who hangs out with, you know, science communicators and engineering teams to work on projects. If there was an apprenticeship scheme established, what would you want it to be focused on? Or would you, if someone asked you, should we focus it on? What kind of things would you imagine?
I think it's a really good question, and I've been thinking and watching as all these kind of words have been appearing on the screen, and I think what comes to my mind most, and obviously this is because this is the area that I work in, but is that there's so much work on Bycatch happening all over the world, and so I think an important part of science communication is that it's not just English language. You know, we're looking at a lot of different research happening in lots of different languages, and from an international perspective or an international policy perspective, you've kind of got different international agreements that are working to provide guidelines on things, or provide kind of compendiums of information. So whether or not that's a resource to tap into through an apprenticeship scheme, you could, you know, have someone be part of the secretariats for one of those things, whose sole responsibility it is to bring that information together. Like in the International Whaling Commission, for example, there's a Bycatch coordinator role there that kind of tries to, that's more on looking at the practical application of things. But I do think one of the biggest challenges is that there's a lot of duplication in work that's going on, because either we don't speak the same languages, or we don't run in the same networks, and so I do think that would be a very valuable tool from a policy perspective, and I do think that there is obviously a lot to be said around how much or how far technology has come as well in the last kind of decade, and how that could be tapped into better. And that, I think that's something more, a more bespoke apprenticeship scheme. But I do think that, yeah, the kind of international policy space is something where it would be good to try and bring all that research together.
Yeah, I can almost imagine it. I might have said imagine a few too many times, but I can almost imagine an apprenticeship scheme connected by people on this call, so that diverse collection of NGOs, research institutes, etc., but in a space where you can say, well, we'll give you an opportunity to come and talk at, I don't know, like the International Whaling Commission, to share what's going on in the space you're working with, the group, the apprenticeship group, but also you can come and share at Clean Catch to local fishermen or something like that, or you can come and share internationally at, I know we're international people on the call, but in different universities, but we facilitate that. So there's an opportunity to go forwards and say, this scheme isn't just siloed to one, workshop with people sat physically there, or one specific discipline. It's a little bit more connected. So there's a really good chance that you'll learn something from those different routes. And then that will again lead to more output and more connectivity and be more practical. So maybe something like that, because what we can do from this webinar and the workshop is go forwards and produce a report to say to the foundations out there that support open practices and want to invest in it, to say there's a great opportunity here in Bycatch mitigation and in development solutions if we did have an apprenticeship scheme that did touch upon that. And hey, we have the network, we have the people out there, we have the routes. It takes facilitation to get going, but again, it's an idea. Maybe it may be something we do. And on here, someone wrote growth pathways at the top there in blue. And I think that's really interesting too, because the reason we kind of worded this to say, what should the scheme focus on, is that there's a lot in that, right? There's a lot to say, well, they're going to do a bit of policy and a bit of graphic design and science and comm, and they're going to also do engineering. There's a whole lot in that. It would have to be, a range of apprenticeships or apprenticeship opportunities working together. So maybe like a cohort or a mini fellowship, dare I say it, but like something like that, but specifically in this space, something like that. Nigel, I know again we've mentioned this about apprenticeship schemes. What's your view on how that would work? Do you think something completely digital where everyone's remote working together like that would work, or do you want something physical? Or what's your view on like where would we focus if a scheme was established?
That's a really good point, actually, something I was discussing only earlier. But I think, I mean, I would certainly advocate some sort of face-to-face on it. I mean, there's online, if you look under the Institute of Apprenticeships, there's quite a few accredited already, but some of them are kind of 2 and 3 years, as I think I mentioned earlier, which take time. And then you obviously you have to get accredited to do that, which adds a big time lag to the system. But I was thinking, you get, to say it's very good point, actually, all the policy stuff. I kind of often say I'm a kind of jack of all trades, and I put that in there because I dip into all this. I do ringing in my own time, so I do kind of frontline conservation. I'm do engineering and do a bit of everything. So I think we need to kind of explore. A lot of people want to be involved, and then I mean it is a kind of conservation kind of as a whole that we want. Is the void that we need to cover. And the more kind of fits we have, whether it be the tech or whether it be comms or whatever, all those sort of things to get people in and certainly get kind of people from the kind of graduates and just coming out, even if don't even have to go to university, just get more and more people into the conservation sector. It just does kind of motivate me, because they're not going to be around forever, and David Attenborough isn't either. So we just to get these kind of communicators and people that are enthused and want to do stuff for the greater good to get them in. So I think you need a balance of kind of online sort of materials that are there, but also some face-to-face, because some people prefer one way of teaching to another.
Well, one thing we can do again with this data we're collecting today is we can approach groups like Wild Labs, so FFI's Wild Labs, to say there's an opportunity. I mean, they're focusing conservation technology, but it can easily branch out to say there's an apprenticeship scheme maybe with Wild Labs to do what you're saying, and then there's an apprenticeship scheme maybe with some of the science comms outfits to have someone physically with their team getting that support, but they all connect together, something like that. So I think there's definitely legs to move forwards and discuss that. And I've noticed we're running out of time. We've only got 25 minutes left, so I'm going to progress us to the next question. This one is by far one of the hardest to answer, but it's definitely needing to be answered. This one is, importantly, why exactly are whales so awesome? And you're not allowed to say they're not. You have to only reply with the reasons as to why they are. And this is because in the report, we need to make sure that the world knows why. So we're going to spend just a few minutes on this one, not half an hour, just a few minutes as to why whales are so awesome. And then we are going to go to Q&A just to make sure there's anybody attending who would like to share any insights from today. We've got a few minutes to do it, well, about 20 minutes. Songs, definitely. That is why. Got about 20 minutes just to wrap up, because there may be somebody who wants to share something. I'm aware that as a panelist, we've been doing most of the talking, so I can give you the power of voice. I can't give you the power of video, because I don't know how to do that in this actual webinar setup. I can give you the power of voice, and you can even have a little say if you want to talk to us about your own views. We'll just leave this one up just for a minute. I think it's nice to include this in our report to our kind funders who helps to run this webinar, because they too may be interested to know the question as to why whales are so awesome. Size, it's definitely got to be that. I mean, my bucket list is still meeting a female full-sized blue whale from a zodiac a few meters away is a win in life. I think who would not want to achieve that? Fab. Bringing in funding. Are we using whales to fundraise for us? The ultimate funding. Okay. I'll give you one more minute, and then we'll move across and we'll get to Q&A, just so we've got the voice of anybody else who wants to share that. And if not, there's a few more things I think the panelists could help with. But in the meantime, I'm going to go back and share the main PowerPoint. So feel free to keep typing away, but I'm going to reshare the screen here because we are going to go back to slide down here. Okay, so you should now see audience Q&A on the screen. This brings us to the last kind of chance for us to go through any outstanding questions because we've got about 20 minutes. And the reason I wanted just to make sure we have this slide is if you want to say anything about today, if you've got any views or would like to pull up anything that we discussed, maybe about the apprenticeship, how you see it working, or anything we discussed today, you can have a chance to say it. If you do want to, and again, don't worry if it's silenced and everyone's quite happy, but if you do, just write a message in chat. Oh, Jonathan Gordon has raised a hand. Would you like the power of voice, Jonathan? I can allow you to talk. I'll give you the option. There you go.
Sorry, I would be very happy just to put it in the chat.
Okay, no problem. If you put your question in chat, we can ask the panelists if it's a question for them and they can reply. Yep, I can actually quickly do it now. I've got the menu up on my screen here. Ben, I'm going to give you the power of voice just whilst Jonathan writes his question. There you go, Ben.
Thanks, Al. I was just going to ask, how do we prove that developed hardware works? Like, is there an opportunity to partner with academia, maybe to provide sort of write papers about open source hardware? How do we actually prove to a wider community that things that have been developed can actually solve a problem?
Yeah, excellent. It's the one question that came up earlier on too, as to the amount of time it takes to do that as well. So how do we go forwards and actually produce viable equipment or solutions, or try different methods? And also, how do we do it cost effectively? Because if it takes 3, 4, 5 years, which it can do in our space, it's a long time to do. Kat, I'll ask you this one because it may be of relevance, but things like CleanCatch, like long-term bycatch mitigation schemes that run for say 3, 4 years, was one of the reasons that was kind of created to try and do that, to give enough time or provide enough time to answer questions as to is it working or not?
Yeah, I mean, I think 3 years isn't long term when you're talking about science, really, right? I mean, I think it is when you're talking about government funding. It's about the best you can do when you're getting to government funding. And I think certainly the intention with that was to try and prevent kind of unnecessary breakpoints that stop work and momentum is lost and all of that sort of stuff. So that's very much the idea of kind of having these multi-year contracts. But again, I just think 3 years isn't a long period of time when you're talking about some of these questions. And when I think there's so much that needs to be captured that has been done, and obviously the Bycatch Mitigation Hub tries to do that, but yeah, I think it's just 3 years is the best you can do in government funding, but still is probably nowhere near long enough.
Yeah, well, it beckons, like Jonathan was saying then, what can we do to develop quicker and more iteratively to say it is having an effect? So again, can openness help us ask questions quicker is one of the a key question. Nigel, do you want to jump in? I think you've got a message here and we'll go back to Dan after that.
Yeah, I mean, that's all very interesting because, yeah, my department, like when we actually something in-house was produced, we would, yeah, the head of department was very much that we got the kind of paper out and, yeah, got a peer-reviewed journal or whatever, which obviously takes a lot of time. And the technology may have moved on in that time. So that was always a frustration. And also that something that kind of bothers me is we don't, as kind of scientists, we don't often write up about failing. So if something doesn't work, nobody knows. And the duplicating of effort that Kat mentioned before, we end up maybe making the same mistake as somebody else because we're kind of not brave enough to put something. Now let's put something out there and say, we tried this, it didn't work. It might have been a conservation impact on the species. It might have been the electronics or whatever. We don't talk about failing. So I think that's something that's a kind of, as a body we should be kind of thinking about generally, is getting that information out there.
Absolutely. That's come up a lot, that because it's very difficult for people to talk about failings because they only want to be seen to be successful, to be able to continue, because it's very, you know, we all know it's hard to be given the opportunity to go and try something, and then unless you wrote it into your remit that it's pure research and you will release it happily saying it did not work because of this. If you've proven, or if you've gone down the other track of we're doing this and we're going to be successful, then who doesn't want to be? Very good point. To communicate failings is essential, really, to help others, and it'd be better if we can do that in a more effective way. Jonathan, you mentioned too there, apprenticeships could be difficult because the field is so diverse. I do agree. I think it'd have to have some real thought process take place. And as you said, what's proven more useful is building collaborations between biologists, fishers, engineers, programmers. Absolutely. In fact, it's what we are building at the moment in the UK in that route through some of these schemes that a lot of the graphics were taken through from today, like the Bycatch idea, to have a really strong collaboration between all of those different disciplines to be successful. And I think, Dan, you touch on that yourself. You said here, a big part of it is having the fishing industry more involved. And that can be from design, advice, testing, end user knowledge, all the way up to funding. So yeah, there's a real desire to still say you need that fishing industry connected, multi-partner. Can't really silo too much. Jeffrey, we'll come back to you in a sec. We've got Jamie here. Jamie, would you like power of voice or would you like to write? I'll allow you to talk in case you want to say something.
Yeah, okay, I'll just do voice. So one of the things about sharing data is that the actual infrastructure for sharing it itself. So coming from a acoustics point of view, for example, if we wanted to share all the data that's being collected on gillnets, of which there has been a large amount, then you could do some great work on a meta-analysis of those data, combine that with databases and fishing effort and things like that. But actually sharing those data is very difficult. There's no unified format for metadata, and there's no unified place to put the data. And universities, you know, those are the types of projects that universities just do really badly. It's a long-term data archiving, or even long-term studies, which are not sexy and not cool, you know, and don't get good funding because they're not the latest thing. So so that's where other organizations could really, you know, and I'm thinking government here primarily, but maybe other people have ideas, but where other organizations could come in and really push things forward. That's me.
No, that is a really great point. I know this doesn't get, you know, that same question gets raised in a number of other conservation technology departments. Let's say camera trapping, or the sharing of passive acoustic data that's collected from, say, audio moths or low-cost passive acoustic recorders. It's the same problem, and you're right. It begs the question that are there specific problems like that, which again you could imagine if done well to start to build infrastructure which is shareable among universities, data collectors, governments, NGOs, where you can bring people in over time who have a desire to work on that from a software perspective, etc., could solve that itch that we still don't have that. I know there are some schemes that have started in other arenas, but you are right. I don't know of one today I'd touch my finger on that would say, in the Bycatch space, where do we share specifically that data? Someone would have to go forwards and put more time and effort in. So that's a really good point. potentially something we would have to take forwards in future discussions to say, what would it take to really focus on that? Thanks for sharing that, Jamie. And then Jeffrey mentioned, is there a feasible / existing approach to reduce bycatch while simultaneously improving the catch of target species? And are there specific training programs or educational initiatives that can improve awareness and understanding of bycatch issues among fishing communities? So I think for me, I think yes, but it's all done in different ways in how you interact with fisheries. There's some that are quite academic in that there are very defined programs with treatment nets where you are literally just looking for catch difference simultaneously. So you'll have treated nets, non-treated nets, etc. And then there's educational initiatives to improve awareness and understanding. I think everyone does it in their own different way. Some of the NGOs will go for a more kind of public consensus on just talking about bycatch in general at policy level. Others will go for very defined local initiatives, which is like whale tourism and other things to say, what can we do to raise awareness of the issue? So I think they're both happening, but very different in where they're happening and how would be my my question or my reply to you there. Okay, just a quick question for you, JP. On that idea of sharing data, I'm very siloed in the UK because that's where I operate from. Over in Bermuda, and even though it's a British overseas territory, is there an implementation of any data sharing schemes that may have happened over there that haven't happened in the UK, or do you have the same problem as Jamie said in that where do you send all this data for local conservation initiatives? Does it exist for you?
I haven't had to deal with it directly. Basically the people I'm working with are the data owners.
Mm-hmm.
So we haven't really had to deal with it. I will say that being a small jurisdiction means that we can immediately know who to talk to and pick up the phone and call them if there is a question about anything, or if there is a bit of data that we know somebody has collected that it's easier to access, as in we know who it is. That makes it easier. But I'm not sure where we stand from a legislative policy, data sharing standpoint either. We're supposed to be following everything that you do as an overseas territory.
Yeah.
But I wish I had a clear answer for you. I don't.
Not a problem. It's just interested to know, because it's a smaller entity, the government have their own kind of way of solving it, but we know it's an issue across the realm. And to you, Kat, your past experience over at DEFRA and CFAS, I'm pretty sure that has come up too, right? Where does the data go, and who creates that all-being entity that accepts all the data? Would you say it's something that CFAS are looking at?
Yeah, I mean, I think it comes up on a number of different levels. One of the key ones being the challenge of fishery reporting, and actually the fact that that's happening on so many different platforms, going to so many different teams in different, in the MMO or in CFAS. And I think that having some kind of universal, a universal way of actually reporting that data, but have a platform that data is accessible where it can be kind of protected. But it's quite a mammoth. It's a mammoth task, and as Jamie said, it's not the sexiest of things to get funding for, but it is something that's likely to make the biggest difference in terms of actually making data accessible across multiple different organizations in different parts of the world. But I mean, I'm not sure if it's something CFAS are working on specifically. I think there's a way of trying to uniform the data to make the data uniform that's coming in from the clean catch work. But I know that on the strandings program side, they've worked through ASCABANS, which is a small cetacean conservation agreement that tries to kind of get that platform so that people can provide reports of standard citations and have it accessible. So I do think there are ways of doing it. It's just a mammoth task.
Yeah, mammoth task, multidisciplinary, lots of coordination too in terms of GDPR, sharing of data, all of that, right? If it was multinational as well, even more so. But it's funny how it does come up a lot in these kind of conversations. And I think it is doable to the degree that from someone like UKRI or someone like NERC or someone to say, how could that be produced to enable that is a good question. And it may be another tick in the, you could do this in the open source space. As Dan's popped up, we can have this as the last question now, but he said the data issue is thorny, which I agree. They're capturing visual and oceanographic data with their products and have a vision of sharing it with the wider ecosystem to solve questions within and outside of fisheries. It has to be done with the end user consent though. Yeah, absolutely, because if the fisherman is using that solution and using it for their greater good, it can be a big question to say, are they willing and able to share it or even want to share it because it's so specific to, you know, their use. And Jamie's saying there are examples, e.g. NOAA, who have a great sharing portal for acoustic data. Well, that's a good point. There's always a good opportunity to internationally chat over with the team there to say, how did that work for you? You know, what can we borrow from that and so on. So there are some good points there. But yeah, I think there's a mix there of data ownership and how to work collectively in that space, and also how to move forwards in actually building something on our side that's going to work. So thanks for sharing that, Jamie and Dan. And with that, we're going to run out of time. So I'll go to the last slide just to say, thank you very much for everyone for joining us today. As I mentioned earlier, the reason we want to do this was to start to talk about where in the open space we can have a dent in the bycatch mitigation space. I think a lot of the questions that you helped answer in the Mentimeter, we'll go back through and look at some of those kind of group findings. And the reason we want to do this too is so we can go forwards with a consensus and produce a mini report, basically saying, here are interesting opportunities in the open space, specifically to move forwards with bycatch mitigation. They may be the sharing of data, the building of tools, the apprenticeships. They could be a whole mix of different things, but we'll take what you've provided today and use it for greater good. And we'll share this recording and the report with you in due time as we progress in our Making Waves sessions. So thank you very much again for everyone for joining us. I'll leave it there for today, and all the best. And thank you to the panelists.
Thanks for having us.
Thanks, JP.
Just me and you now.
Hey, JP.
Hey, sorry. Yeah, I was quite distracted. I had to deal with booking a hotel room.
Oh, no, that was great. We got, we had 35 people sign up and we got 27 people join, which is way better than I actually even thought.
Great. Yeah, sorry. I'll be more attention next time. And we're just not doing much bycatch specific stuff here, so it wasn't quite in my wheelhouse.
Yeah, I wanted to get you in because when I write this report for the foundation, saying here's what we can do in open source space, I wanted to have Station be in there too as an entity that is trying to enable the testing of ocean tech, because it will easily lead from, you're not doing bycatch, but you are doing everything else. So when we
should be doing
bycatch,
and we should be doing bycatch, and it would be interesting to learn more about what's out there to see what we can do to help. with some
Yeah,
of that, you know?
exactly.
I mean, there's
Exactly.
specific applications here that I could think of that would be interesting. We're not doing whale bycatch because we don't have an issue with that, you know. But it'll be interesting to see how, whatever. Yeah.
Yeah.
Cool.
Well, I'm going to catch up with you on those lobster pot tags. I did talk to my team, but then I had to get stuck into like making this deck and getting the whole making waves thing done. So I kind of got consumed by that. So I've got to jump now.
Call with her today. I'm going to try to reach her the next day or so to get a better idea of what her wish list is. You know, what exactly she wants to accomplish with this.
Yeah, absolutely.
I'll do that right now. Actually, now I've got I've got 24 hours. My family's not here. So,
yeah, all those jobs you can do, right?
They're basically coming back. The main thing is they're coming back a week early because they fly for free because my mother-in-law works for the airlines, but they were in Japan, but it ends up that the flights were all booked all through August, so they had to jump on a flight last night out of Japan, and then they were in San Francisco last night, and then they landed in New York today, and then they got bumped off the New York flight. So free flights are great until they're not, you know. Now we've probably spending more on hotel rooms than we would have been.
Yeah, but you would have on the free flight, right? Oh.
Yeah. So
yeah. Well, anyway, enjoy those 24 hours. I've got to jump on a call at 5 now to debrief on this. But if you ask the lobster contact more detail, I spoke to my team; they're aware of it. We can have a sync up very soon, and we can go from there. But thanks again for joining us today, JP.
All right, thanks.
Very
Thanks.
welcome.
Yeah, thanks. All right, take care. All right, bye.
Thanks. See ya.